So here, when we get one of these problems, right, the first order of business is to write down the mean, right? We see this problem, the SAT is a test given to about 1.7 million people a year. This is our total population, right? And can be modeled with a normal distribution. This is key because this tells me that I can do stuff in the first place. Scores on the math section have a mean of 500, so I'm going to write 500 in the middle, and a standard deviation of 100. That means that each one of these little dots is going to go by 100 each time. 800, and then going down, it is 400, 300, and 200. Scores do not go below 200, and there's a maximum score of 800, and that's what it shows on our graph, does it not? Sit. All right. Label the mean and values for standard deviations 1, 2, and 3, and negative 1, 2, and 3 on figure 3 given the information above. Well, that's what we just did. What percent scored between 400 and 600? So that's between these two intervals. And if we remember the empirical rule, this is 68% because this is 34 and this is 34% each. So this guy is now done. What percent scored above 600? So we find where 600 was written there, and we add up the percentages from here, here, and here. This guy is 13.5%. This guy here, so that's this guy. This guy here is 2.35%, and this guy here, everything remaining is 0.15%. So we do 13.5 plus 2.35 plus 0.15. These two together is 2.5. 2.5 plus 13.5 is equal to 16%. So this guy is now done. What percent scored between 300 and 700? 3 to 700 is here. That is 1, 2, 1, 2. That represents 95% of the data. So our answer is 95. What percent scored below 400? So where is 400? We marked it at -1 standard deviations, and below 400 means to the left of 400. It is symmetric, right? So we said that from 600 to the right was going to be this. So therefore, 400 will be the same. So that's also 16%. And if 1.7 million people take the test, approximately how many people score above 700? So we need to do the percentage that is above 700, which is 2.5%. Right? 700 to the right is 2.35 plus 0.15. We add those together and we get 2.5. So we need to rewrite this as a fraction. So that ends up being 2.5 over 100, which is equal to 0.025. And then we have to multiply this by our total population times 1/700,000, right? We multiply that and we should get our answer, which ends up being approximately, so if we take out the 100 from here, remove these two, we end up with 2.5. Do I want to do it that way? So if we remove 1 0, we end up with 0.25. So now I can divide this by 4, right? 0.25 is a quarter. So what I can do is I can divide this by 4, and that ends up being dividing by half twice. But anyways, you can put that into the calculator. You should get divided by 2, 17, sorry. is 16 is the closest number, so we get 16, 16.5. Okay, so 8.5 divided by 2 is what? That's right, 4.25. So 4.25 with 4 trailing zeros. Should be roughly 425,000 is my guess.